Hey, we're looking at graphs again. It's been a long time. So let's look at this graph real quick. We're going to start off with a distance time graph. And the things to remember on distance time graph is that the slope rise over run is the velocity. Yes, it is. So just like a normal slope, if the slope goes up, it's a positive velocity. If the slope goes down, it's a negative velocity. And if there is, whoopsie, and if there is no slope at all, it is zero velocity. Just a quick reminder of that. Um, so when you're doing these graphs, straight line, constant velocity. Okay? Straight equals constant. And this is a distance time graph. Hey, you want to know what acceleration looks like? Well, let's look right down here. Acceleration is going to be a curve. And remember the happy curve. If it has a happy face curve, that means that it is curved up like a smiley face, either side of that smiley face as pictured. Either way, it is a positive acceleration, right? They won't look like a happy face necessarily, but they're half of the smile. Oh, if it's a mean old frowny face, then we know it is negative acceleration. Okay, so just remember those shapes. I don't think this is on the review, but the tangent of the curve is then, of course, the instantaneous velocity, which means the velocity at that moment. Oh, you want to find the what else we have here? Constant velocity, blah blah. Oh, if it goes, oh, that's a velocity graph. Okay, so if you want to use a velocity graph, the velocity graph is really simple to use. Uh, it's just velocity versus time. So if it's constant velocity, it's going to be a flat straight line parallel to the timeline. Yes, it is. And if it's above zero, it's positive. If it's below zero, as pictured here, it is a negative velocity. If there is any kind of slope, and I believe this was the original picture here, if there's any kind of slope, it doesn't matter where it starts. It could start at the zero, it could start below zero, it could start above zero. If there's any slope at all, that means acceleration. And then where you're at on the line depends on the what is actually happening. So remember, we can have positive acceleration, and I'm gonna do a little erasing here. We could have positive acceleration. Can I get that? Yes, I can. Positive acceleration, but we are moving backwards, right? Because we have negative velocity. And now that means that we are starting going backwards fast and slowing down to zero, but it's in the positive direction. Then after we get to zero, we continue to accelerate to a true faster speed. Okay, starts off going backwards very fast, and slowing backwards, it goes to zero. And then after that point, still the same acceleration, it is now getting faster again. This would be like if you had your car in reverse and you took it and you jammed it into drive as you were backing up. Not good for the car. Don't do that. Okay. So that is the acceleration is the slope in a velocity time graph. If there is no velocity at all, it will be a flat line on the zero. Finding the distance. Oh, here's negative acceleration. Let's do that first. Negative acceleration is the same idea, but the line is a negative slope. Slope of the line velocity time graph is acceleration. So we're going really, really fast forward and we slam on the brakes and we stop. But this crazy guy must be on a hill or jammed it in reverse. I don't know. Because then he started backing up faster and faster and faster and faster and faster. All still negative acceleration because remember, acceleration, negative and positive, and velocity, negative and positive. Those are showing us the direction of the vectors. All right, so you want to find out how far you're traveling in a velocity time graph. Remember, I didn't say this, so I'll go back. Distance in a time velocity graph is just the distance. You just go to where the distance is, right? You just go across and you're there, right? Now, on these, it's the area under the curve. Now, I say under the curve, and remember we said this before, just because Mr. Arnold says under the curve, it doesn't mean that the curve can't be upside down. It's the area from the zero displacement, right? From the zero line. So if you're finding a square shape, it's base times height. That's the area, which is the distance. If you're trying to find a triangle shape, it's 1/2 base times height. That equals the triangle. Again, that's the distance. Okay, that should help you out with that first graph stuff. There's nothing really tricky in there. You just have to think about it a little bit. So good luck with those first questions, and I hope that helps. Thanks.